I'm trying to make a brief video talking about how um, signal propagation works indoor, which is not that different from the Rayline model, which is not that different from how signal propagation works both on a very long range and when you have plenty of obstacles, so say cities. Oh, I got lucky. One of the biggest, say, components of that signal propagation model, of that channel model, is called frequency selective fading. Now, frequency selective fading, as you can probably imagine, is fading of your channel, of your signal channel, carrier channel, whatever you want to call it, at a very specific frequency. Now, that frequency depends on the position of the objects inside your room or your city, or the position of your antennas. And I believe you can see where I'm going here. That's our 10 megahertz spectrum, and I'm moving my hand, which is over here, by the way. It's just a couple of centimeters away from the camera, and 1 meter away from both antennas. I'm moving my hand ever so slightly, and there are a few positions where I can put my hand and get our channels fading. At least I could do that a couple of seconds ago. Let's see if I can replicate that. Not really. What changed? There you are. Please. Okay. So by having my small finger in a very specific position, I can have the right hand side of the spectrum fading, which is what the point I was trying to make here. And by moving said finger across the room, I can have different parts of the spectrum fading. All of the black you see on the screen right now, where it's supposed to be, say, a darker shade of green, that's fading. That's the signal which is not being received by the receiver for that very specific frequency. Now, the way you fight that is by having multiple antennas. As you can imagine, given the very small movements I'm making in my hand right now to have that result of the receiver, if I was to have two different antennas, say 10 centimeters away, 5 centimeters away, alpha wavelength or a full wavelength away from each other, then I'm going to have completely different received signals. And by using a technique called maximum ratio combining, I'm going to be able to combine the two received signals into one and pretty much get rid of the frequency selective fading, which is much better right here. So that's my hand. That's the small movements I'm making with my hand, and that's how that looks like on the spectrum. Of course, transmitter and receiver over there, somewhere. STR receiver. Well, that's it. So you have two antennas. You can combine the spectrum. The receive signal power of the two antennas into one. And instead of getting this very, very wobbly received signal, you're going to get a very stable and boring FDM waveform just like that. Which is what this system is going to make with these two receiving antennas. I mean, I want to underline one last time how crazy this is. So, unfortunately, I can't have a view of both this spectrum and my hand at the same time, but this is the movement I'm making in my hand, going from here to here. And that's what that looks like. Okay? It's insane. It's just complete insanity, if you ask me. It's fascinating. I honestly, you should buy a SDR receiver and you should play with this because it's insane. It's... I don't know. I love it. Anyway, that was it. I hope you have a nice day. Enjoy.